Okay, it's day 405 off the grid, and today has been an extremely hot day. I haven't been able to get too much done outside because of the blimmin' heat, but I did manage to install a new fly screen on the back door, which has helped massively. But now that things have cooled down a wee bit, I've had a chance to do a wee bit of work on the power supply for the real-time diversion controller, the permanent power supply. So I don't think I can talk about the power supply without talking about this battery. This is a UASA U-cell 38 amp hour battery, 12 volts of course, but its capacity, its real capacity, is nowhere near that now. In fact, it's so low in capacity most people would just scrap it, but I'm not going to, because this is a bloody minded thing. You see, in 2012 when I started getting serious about solar power, we went all the way down to Wellington and bought off a guy, and these were from Trade Me, 8 of these batteries. I paid $40 for the 4 best ones that he allowed me to pick out, and then the next 4 he said I could have them for 15, so I grabbed another 4. You know, so I came back with these batteries and thought, oh, this is going to get my off-grid system going off to a flying start, but one by one they very quickly fell over. Now, I was smart enough to do my usual test that hasn't failed me since. I always take along my halogen bulb. In fact, I have it here. Put this bulb across the battery that I'm testing and measure the voltage with a multimeter, and if it sags too much then I know the battery's a bit duff. Well, I did that. That was the first time I did this. It's never failed me since to evaluate batteries, but it returned these 8 batteries that I took as good batteries, but within a couple of cycles they all started not behaving that well, and slowly but surely they became 10.5 volt batteries, you know, with cell down, and well, now we're down to the point where pretty much all of them have become pretty much dead weights. I'm using them as weights and stuff like that, which you might have seen on my other videos, except for this one and this one. Both of these will sit at around about 10.5, so you know, they're not any good for much. You can really only run things off them in the order of literally milliamps, so to all intents and purposes they should be chucked. But I'm going to use at least one of these permanently on my system. I've just got to find a role for it that it is capable of performing in. Well, my real-time diversion circuit needs an isolated supply of around about 10 to 15 volts. It's not too critical, it just drives MOSFETs, and the whole circuit itself only draws a couple of milliamps. But that supply has to be isolated. You can't take it from anywhere else because it's completely floating. So this is what I've come up with. At the moment I've just been using batteries just to run that isolated voltage, but I'm getting tired of periodically checking them and swapping them out, so I thought it's time to do something permanent, and the UASA is going to be part of that. But I've built a power supply, so here it is. This is built, it's originally the base sort of power supply unit of an old Hills, and here's the front cover, masthead amplifier for a TV aerial. I don't have the amplifier, I've only ever had the base, so I thought this might be a good little box to start building something in. I mean, I need most of the stuff in there already. Which of course, this is the power transformer that it came with. Turns out to be about 28 volts AC, that transformer. So what I've built here is a very baby little constant current power supply. So it's a capacitive dropper design, which is unusual in a relatively low voltage power supply. I mean, you see people using capacitive droppers all the time to, you know, drop the mains down to a low voltage and create some rather dangerous power supplies. I think they're kind of dangerous. I mean, apart from the fact that if anything goes wrong with them, you're going to have full mains on the output. What I think, in my view, is more dangerous is when you plug them into mains voltages that aren't pure sine waves, like modified square wave inverters. Those capacitive droppers tend to get a bit hot and sometimes they fail. But anyway, I'm using this quite differently. So I've got my transformer, which gives me isolation, which is key. This, yes, is a capacitive dropper, but I'm looking at it more as a wattless resistor. It's creating resistance, which they basically do in a capacitive dropper power supply, but of course they don't dissipate any heat. Well, very little, you know. So it means that this is quite efficient. It means it's drawing very, very little power, and that's important because this is going to be running off the 24 volt inverter. Yeah, it's a bit of a round robin situation actually. This will run the real-time diversion controller, which helps charge the battery, which runs the inverter, which powers this. But you see, of course, that's the key, having the battery over there. If the power goes down, the battery will carry things over. Right. So, output of transformer goes through the dropper cap. That's fed into a full wave bridge rectifier. I just pulled out this one because I couldn't be bothered making one out of diodes. I could have actually just used little 1N914s. The current here is so low. Basically, with this capacitor, which is 0.68 microfarads, in fact, if you read the color code, you can even get that idea there. It's one of those old, you know, licorice style capacitors. So through the transformer, through cap, through bridge, and then we've got a DC output at these terminals here. I've put a Zener across there just so that the unloaded output doesn't get too high. I really kind of wanted about a 15 volt Zener, because that would kind of protect the battery as well if it decides to come alive, but I didn't have one, so I just bunged in an 18. It'll do. And this is going to be the battery input here, where this red clip is, so it's fused. That little wire link there, I don't know if you can see that on camera, is actually a piece of 5 amp domestic fuse wire, so it's fused at 5 amps. Obviously if it blows I have to disassemble the whole thing and solder in a new fuse, but I don't really expect it to blow. But hey, it's there just in case. The fuse down there protects the transformer, so if anything goes wrong with the transformer, well, you know, gets loaded up. That one will blow. That was the original fuse in there, but you know, that's probably not going to ever blow either. So that's basically the power supply, how it works. I've got it currently running. I've had this running for a number of days now, you know, since I put up my last blog about this particular circuit. But it was everything was all connected in with clip leads. The capacitor was. There's a little electro under there across the output to filter it. Of course, that was all connected up with clip leads. And as you can see, it's currently pushing the battery up to 12.728 volts, which is, it sits around there, so that's pretty cool. Naturally, if I disconnect the battery, it'll jump up higher. In fact, if I unload it, it'll jump up to about 14. At the moment, these clip leads here are connected to the 6.8k resistor, which is a simulation of the real-time diversion controller's current draw, although obviously it'll draw it in pulses. This is just a constant resistive load, but it's a rough equivalent load. So that's basically it really. I kind of just wanted to build a passive component design. I didn't want to put in any active circuitry, any voltage regulators, anything like that. I wanted to just kind of do it all with passive components, I guess. I mean, you know, a Zener diode one could argue is almost an active component, but it's still a 2-terminal device. It's not a 3-terminal like a transistor, is it? So that's what I'm going to do. So I've just got to find a nice place to mount this in the shed and plug it in to the inverter, and then put the wiring through permanently to the battery and to the real-time diversion controller, and then hopefully it'll be a walk-away job and I won't be worried about it again. Although no doubt I'll check on it from time to time to see if the voltage is raising on the battery, but I doubt it will. Well, I think that's really a long enough rant now. I may get it installed today, I may not, so if I do get it fully installed, I'll make a video. If I don't, this will be it. So when I say that was day 405 off the grid. Oh, actually, while we're on the subject of these batteries, there is one more in use. It's actually running a little multimeter that monitors the voltage on the 24 volt bank in shed A. That's got to be an isolated supply as well, but it's even more shot than these two. The multimeter, like this current, is measured in microamps, and it's actually got a little 1.2 watt solar panel constantly topping it up anyway. So yeah, I guess of course I could have just had a small solar panel doing this, but this was kind of easier, and it's really not going to make any impact on the load that the inverter's supplying, because that, oh, there's my multimeter. The inverter's always on anyway, because that's the inverter which runs the fridge and the freezer. So there we have it, day 405. Beep beep beep. Right, this is your hanging garden, eh?
Yep, it's only on level 1. It's only we only hang it on a tree because we haven't got a bigger greenhouse. Once we get a big one, we're gonna get these big large hooks.
What have we got here?
We've got hanging garden. This is these are all around here. There's start 6 of 6. Those green ones are basically fireballs, and all these other ones all around here. The green ones are the fireballs, but all the other ones around are not fireballs. They're just random ones that I picked.
Okay, cool.
So basically, Dad over there, he found a useful place for me to hang it, and also Mum helped me with that once I couldn't handle it because of mosquitoes, and I think that's it.
Okay, cool.
I can say day off the grid.
Yeah, it's day 405.
Off the grid.
Yeah.